Hello friends, in the last video we have derived various pdV work done relations for various quasi-static processes. So in this video we will try to solve some numericals based on those concepts. So the first numerical is an engine cylinder has a piston area of 0.1 meter square and it contains a gas at a pressure of 1.5 megapascal. Now the gas expands and the final pressure is 0.15 megapascal. So we have to find out the work done by the gas on the piston. Okay, so let us solve it, and the stroke length is given as 0.30 mm. Okay, so this is the problem. The gas is expanding and this is the cylinder and this is the piston. So since it is expanding, so let us consider this as the state 1 and it is expanding in this direction to state 2. Okay, so now if I try to plot the pressure and volume in a PV plot, I will get something like this. So it is expanding in this, it is going in this direction in a straight line. Okay, so now I have to find out the work done during this process. So we know work done is given by the area under the PV diagram. This red part will tell you the work done. If I can find out the area of this part, it will give me the work done. So let us now write the given data: V1, P1, P2 and the stroke length. Everything is given. So now we have to find out the work done. So if I draw the same figure in a bigger scale, I have to compute the work done under this 1, 2 line. So what I can do is I can divide this area into two parts, triangle and a rectangle. So it is easier for me to find out the area of a triangle and the area of a rectangle and then add it. So this is one of the approach. Just find out the area of the triangle and the area of the rectangle from this figure and add it. Okay, one more approach is that this figure, if you see it carefully, it looks like a trapezium. Trapezium is a geometrical figure which has two parallel sides. So I can also find out the area of the trapezium and this will tell me the work done during this process. Okay, so just for the sake of revision, if you have forgotten the formula of trapezium, suppose I am drawing a trapezium here. It has two parallel sides, suppose A and B. These are the parallel sides. Now I have to find out the area. So it is half into sum of the two parallel sides. Let me name it as A and B. Half into A plus B into the distance between the two parallel sides. The distance between A and B. Let it be H or L, whatever you like. So in this diagram, now I'll try to apply this formula. Let me name it as ABCD. So it will be easier for me to do the calculations. So now what is the work done formula? Half into length of the two parallel sides. So it will be AD plus BC into the distance between AD and BC. This distance, let me call it as L. I can name it as L. So this is just a distance. Okay. So now if I compute the values of AD and BC, what is AD? AD is nothing but pressure P1. Okay, AD is same as the pressure P1 and BC is equivalent to pressure P2. Okay, so I in place of BC I can put as P2 into the distance between AD and BC. Now this distance, it is actually the difference of volume V2 and V1. Okay, now we have to find out V2 and V1. What is V2 minus V1? So first in place of P1, let me write it as 1500 plus 150 in kilopascal. I have converted this into kilopascal. In the question it was given in megapascal. Okay, so now what is V2 minus V1? It is actually a volume. Okay, so from the if I can refer from the diagram, this is V2, this is V1. Okay, V2 and V1. So V2 minus V1 will be the middle portion, this portion. That is how much the piston has actually traveled during expansion from state 1 to state 2. what volume the piston has traveled. Okay, this volume. From the PV diagram, if I show you the same thing, V2 minus V1, so this portion, okay, from 1 to 2, how much the piston has actually traveled, this is del V. Okay, so it is a volume, so volume means area multiplied by some distance. So here piston is moving, so area of the piston into what distance the piston is moving, that is the stroke length. It is given in the question as 0.30. Okay, one small correction, the piston area is given as 0.12 meter square. It will be meter square, not cube. Okay, now let me now substitute the values. Just just by substituting in the values, I will get the answer. So this will be 1650 into area of the piston into the stroke length. Okay, so if you do this, you will get the answer as 29.7 kilojoule. So one more approach, as I told you, I can first find out the area of the triangle, and then I can find out the area of the rectangle, and then if I add it, I'll get 29.7 kilojoule. Okay, so the next problem, a mass of 1.5 kg of air is compressed in a quasi-static process from 0.1 megapascal to 0.7 megapascal, and PV is equal to constant here. The initial density of air is 1.16 kg per meter cube. So we have to find out the work done. So let us try to first write the given data, mass, P1, P2 and density, and let us convert P1, P2 in terms of kilopascal. So we have to find out the work done in this case. Okay, so now here they have given that the product of P and V is constant. That means it is a case of isothermal process. Okay, so we know that work done during an isothermal process can be written as P1 V1 ln V2 divided by V1, or we can write P1 V1 ln P1 divided by P2. Any one of these out of these two formulas, we can use any one formula, but we will use the second one because P1 and P2 values are given in the question. Here it is given in the question. Okay, so but from in this relation, the value of V1 is not given, so we have to find it out separately. How can we find out? We know density is equal to mass by volume, so very easily I can find out V1 from this relation. V1 can be written as mass divided by the density. Okay, mass divided by the density. Now write the values 1.5 divided by 1.16. okay, so if you do this calculation, you will get the answer as 1.29, around 1.29, okay, meter cube. Now let us try to use these values in the previous relation. So P1 is 100 kilopascal, V1 is 1.29, just now we have found it out, ln P1 by P2. Okay, so if you carry out the calculations, you will find the answer as minus 250.89 kilojoule. Now why it is minus? This minus implies that work has been done on the system. Okay, work has been done on the system by the surrounding. So this is the implication of minus. So this was all about today. We will do some more numericals in the subsequent videos. Thank you.